Final video on NLP, we are going to look at semantic textual similarity and passage ranking. Okay. Now, if Hugging Face add any more NLP tasks to its pipeline, I'll create more videos. But for the time being, this video cover all the NLP tasks. Okay. So here we are not using pipeline because this is not yet the part of the pipeline. Here we are using this sentence transformer. Okay. And the model is this one. So we have a model which can do the sentence transformation. But what transformation? It given text as an input, it convert the text into word embeddings. Okay. So as I mentioned in one of the earlier videos, if you don't have the model in your cache or in your local system, so when you run this for the first time, the model gets downloaded. For example, this model 90 MB. It is the actual model. I guess this is the actual model. So as you can see, this model is about 90 MB in size. Okay, so this gets downloaded to your local machine. Now, so here we have two sentences. We are going to use this sentence transformer, which is basically going to do the word embeddings for us. Okay, so we call the model with encode and we supply the first sentence, I am happy. Okay, so convert to tensor. So this is going to return the word embeddings. So we have embeddings 1. And then for the second sentence also, we get the embeddings. Now we'll discuss in a separate video what embeddings are, etc. But in short, the computers don't understand text, right? They can understand only numbers. So what we do is we convert the text into some higher dimensional space with numbers, okay, represented by numbers. Those that we called as embeddings. Now these embeddings have context, some more intelligence to it, right? So for example, when we say cat and dog, they can say, okay, these two, they probably don't know they are as animals, but they can see these two go together often. They probably represent a similar thing, and they sit close to each other in that very high dimensional space. Okay, so the embeddings are a way to convert text into some vectors, and that vectors have some meanings, and on those vectors we can do some mathematical operations like which one is the closest, right? So that means for a given word we can find the closest word, which one is the farthest, we can do which one is similar, that type of mathematical operations we can do. Okay, so here we are doing one such operation, right? The cosine similarity. So here we have a vector, here we have another vector, and we are finding how similar these two vectors are. Okay, so it will return a response between 0 to 1, and in this case it returned 0.6. Now here we have two other sentences. Well, one of them is the same, but the second one is I am very happy instead of I am full of happiness. So let's check which of these two sentences, either these two sentences are close to each other, or these two sentences are close to each other, are semantically more similar. Okay, so we are doing the same thing. So we are calling the model to create the embeddings for this one and then for this one, right? So we have the both the embeddings, and then we are computing the cosine similarity. Okay, so this time it has written 0.9. So the model is saying these two sentences are more similar to each other than these two sentences, which makes sense, right? So that's the semantic textual similarity, right? So far, in all the videos, we have used pipeline to do the inference, right? So as we discussed, there are two methods to access these thousands of models or the transformers developed by Hugging Face. One is download the model artifacts to our local machine and then do the inference. And the second method, which is more likely scenario if we when we go for production, is to create the endpoints and then access the models via APIs, right? So we are going to do that. So here I'm defining a function which simply make a call, right? Which simply uh, makes an API call or hit an endpoint, right? So it requires three things. One, where do we want to go, or the URL or the endpoint we want to hit, right? So this is our API URL, sentence transformers, right? And then the headers. So the headers typically contains the authorization, the input output formats, the payload formats, etc., right? So in our case, the header is simple. We are simply supplying the API token. Now you can go to Hugging Face website and register an account. It's for free. You will get the API token, okay, under your user profile. And then finally, the payload, the task we want to do. So this is the input we are giving it to the model, okay? So using the requests library, we are making a post request here, right? By supplying three things. The endpoint we want to hit, the headers, which contains the authorization, and then finally the payload, which describe the task, okay? So here our payload, here we have a source sentence, I am very happy. And here we have two target sentences. I am filled with happiness and I am happy, okay? So we call the API and it return the similarity score uh, between our source sentence to our two target sentences. So I am very happy is more closer to I am happy than I am filled with happiness, right? So that's what the result is saying, okay? And the final task and the 18th task is the passage ranking, okay? Again, we are going to use API, not the pipelines. So sentence transformer. So here is our model, and this model will do the passage ranking, okay? So again, API header, and now the payload is this, right? So oh, with the passage ranking, we might have many documents, right? So we want to rank the documents uh, uh, so that in the order of their relevance, right? So here we have a source sentence. We have a bunch of other sentences. Now we want to rank these sentences which are similar to this one, right? So for example, Google, when we do Google search, this is what happens. So it find out all the pages and it rank those pages and it display the pages in the highest to lowest ranking, okay? So our source sentence, that is a happy person. And then here we have three target sentences. Uh, Again, for demonstration purpose, we are using such short sentences, but these would be typically documents or paragraphs, right? For example, let's say we might want to find out all the articles related to sports or politics, etc., right? So there we will be using the full article content. All right, so these are our sentences, and the model has replied the ranking or the relevance score for each of these three sentences. So our source is that is a happy person. Now among these three sentences, that is a happy dog, that is a very happy person, and today is sunny day, right? So among these three, the middle one uh, will have the highest ranking, right? So the score is 0.98, okay? This one is followed by that is a happy dog. So that is a happy dog is more similar to that is a happy person compared to today's sunny day, right? So the second score, which is this 0.8, goes to this one. And finally, the third sentence, today is sunny day, it has a score of 0.65. Okay. So here we are just ranking some documents in the order of the relevance to a source document, right? Now the semantic textual similarity, we use it for use cases like information retrieval, clustering, etc. We want to group some documents based on their relevancy. Again, the same example, we have a bunch of articles, right? We don't know which article is which. So we might want to do some grouping based on some politics, sports, some entertainment, etc. Okay. That's all for today. So with this video, we have covered 18 natural language processing tasks we can achieve using the transformers developed by the Hugging Face. Okay. And next we will see the computer vision related tasks. Thank you.